Now we're going to learn about concavity and second derivatives. We're starting out with a function. We're only going to use the graph in this presentation, and we can see from the graph that it is a cubic function. Now we're going to start by trying to figure out where the function is concave up. That means where it is concave up like a cup, is how people usually say it. Or you could think about it as the hill in the valley, and where it is concave up would be the valley area, where it would be able to hold the water. So you can see here that it's about, let's say, x equal to 1 to x equals infinity, that it looks that the function is concave up. Now we're going to take the function away and put the graph of the second derivative right there, and you can see that in the area where the function was concave up is the same area that the second derivative is positive. So that's our first relationship, that the second derivative is positive when the original function is concave up. Now we're going to look at when the function is concave down. That's about from 1 to negative infinity. You can see that it looks like a mountain right there, a hill, rather than a valley. And then it would not be able to hold any water. So again, we're going to take the function away and bring in the second derivative, and you can see that the second derivative is always negative when the function is concave down. So that's our next relationship, is that the second derivative is negative when the function is concave down. And now we're going to look at when the concavity changes. So we can see right there is where it goes from concave down to concave up, where it sort of switches. That is where the tangent lines start to become more positive, because on the left-hand side of the graph, there's the tangent lines is slowly becoming more negative, and now on the right-hand side, the tangent lines are slowly becoming more positive. So now again, we'll take the graph away and put in the graph of the second derivative. And if we just move our point vertically upwards, we'll see that the second derivative is 0 when the concavity of the function is changing. And we call that point an inflection point. So in conclusion, our first relationship is that the second derivative is negative when the function is concave down. The second derivative is positive when the function is concave up. The second derivative is 0 when the function has an inflection point. That is when the concavity is changing from down to up or up to down. And just as a way to remember, you can think concave up like a cup. So when the function looks like a cup, that's when you know that it's concave up.